Now, hello everybody and welcome again to our webinar with Niklas Moldenhauer, Engineering Manager, and Mark Vonetran, Software Engineer, both in the Gartner team at SAP. You will get an overview on Gartner and hear how and why it was transferred to the NeoNephos Foundation recently under the umbrella of the Linux Foundation Europe. And we would like to discuss your questions related to this open source solution for managing Kubernetes clusters at scale. So bear for the Q&A or use the chat. And a very warm welcome to our speakers, Niklas and Mark, who, by the way, were both at the Gartner user side before switching to the Gartner team. And with that, I would like to hand over to Mark and Niklas.
Thank you for the nice introduction, Ulrike, and hello everybody from our side. Welcome to the session about what Gartner is in the context of the newly founded NeoNephos Foundation. Ulrike already did a great job at introducing today's session, but let's take a look at the journey that we have planned for you today. We would like to start with the problem statement, basically the problem that we're trying to solve with Gartner, to give you a little bit of the history and the motivation behind the project. Once we covered that, we'll move into what is the Gartner project? What are the components that constitute it? What is basically the unique selling point of it? And then, of course, the focus on the NeoNephos Foundation, the project being donated to the NeoNephos Foundation and put under its governance. With all of that out of the way, we'll show you how Gartner works by doing two things. We'll take a brief look at the technical architecture of Gartner, but also give you a live demonstration of how it works and what it looks like. And finally, hopefully before the sun sets today, also depends on where you're joining us today from, but we'll give you an outlook basically of, well, where are we now with Gartner and what are currently the new focus topics also under the umbrella of the NeoNephos Foundation that we are working on along with the community. All right, let's jump into the problem that we're trying to solve with Gartner. Quick recap of the evolution. So before Kubernetes got really popular and widely used, basically the atomic unit used to be a server or virtual machine that you use to host your services. Nowadays, we don't think about that anymore, but rather you're managing either one, maybe a few, maybe even many Kubernetes clusters in a complex scenario. So that brings us to, well, I want to have a Kubernetes cluster, but then I have to answer a few questions. What requirements do I have for my Kubernetes cluster? A few questions that I need to answer are, what is the version that I want to be using or can be using with the components that I want to deploy or develop myself? What is the operating system, or in the context of Kubernetes, let's say the Linux distribution that I want to use for the cluster nodes? Yes, I'm glancing over Windows-based Kubernetes clusters here. That's another thing we need to answer. And of course, questions like, how do I want to scale? What are the metrics? What are the signals that I want to use? Typical scenario is TLS certificates. How do I provision them? How do I manage the life cycle of them? And of course, the Kubernetes API server also has a plethora of configuration options that I need to take care of. And then even with all of these questions out of the way, I still need to ask myself, okay, I have my requirements, but how do I get the Kubernetes cluster now? There's lots of choices. I could do a Kubernetes in Docker. I could do a Minikube, use kubeadm. Or, of course, all of the major infrastructure providers also provide their own distributions, and many others as well. What's true for most of them is that they are usually really tied closely to the infrastructure that they run on, and there's obviously opinions baked into them. And by this point, you might be wondering, why are we looking at a picture of two different trees in fall and winter? Well, you can draw the comparisons that Kubernetes clusters in that sense are a little bit like trees. So both of these trees belong to the same botanical category, but as it's hopefully obvious, they differ in terms of size, color of their leaves, whether they lose their leaves in winter or not, growth potential, and others. And the same is in a sense true for Kubernetes clusters, meaning that they are all a Kubernetes cluster, but they behave different, maybe they scale different, and they have different opinions baked into them or configuration options available. Now, if you work through all of these different vendors that provide Kubernetes distributions, you will probably end up with a rather small overlap of common configuration options. And then you need to ask yourself, okay, do I lock myself in with one specific provider? Is it the best choice? Maybe it's the best choice now, but not in the future anymore. Or also, if we think about the hot topic of computing or data sovereignty, then maybe you want to have control over the infrastructure or at least spread your risk across multiple providers. Now, moving on from just a single or few Kubernetes clusters, well, what if you want to manage multiple clusters potentially across multiple infrastructure providers? So obviously we're aware that's a bit of a complex scenario, but for SAP, it's the case that we run with a so-called multi-cloud strategy, meaning we want to do exactly that. We want to use the major providers. We also employ our own infrastructure, and we want to make sure that we can run on all of them. But that brings us to the point that we need to find a way to manage basically a fleet of clusters, while at the same time, from a technical perspective for a company, needing to make sure that we set certain guardrails. Basically, these requirements that we talked about before, right? What are the Kubernetes versions that I can use? What are the Linux distributions that operate the nodes of these clusters? In an enterprise context, that's probably something that you want to control. And that brings us, or brought us then back in 2017 to the decision for SAP, do we buy an off-the-shelf solution that helps us to achieve that, to achieve this multi-cloud strategy, while at the same time running homogeneous Kubernetes clusters on top of them, since we want to deploy the same applications everywhere? Or do we build our own solution, basically make it ourselves? And I think we wouldn't be here today if we didn't end up with the right path here, the make path. So that brings us to Gardener, or the Gardener project. Fast forward today, now we have Gardener. Kubernetes runs on an uncountable probably number of infrastructures. And basically what Kubernetes needs to do that is the primitives of computational power, storage, and network. This is what the platforms provide, either as a cloud service or maybe you have something self-hosted or on-premise. But usually what you also need is a so-called cloud controller manager that basically talks to this platform, is able to work with its APIs. You're also having a container storage interface or network interface on all of these components and basically enable this platform to run Kubernetes. And this is exactly what Gardener is about, right? We want to use these primitives to run Kubernetes and make it work the same way on top of all of these infrastructures. So the tip of the iceberg is I have a Kubernetes cluster. It runs on a plethora of infrastructures. And we pull in this layer of Gardener in between as kind of an abstraction to operate and manage these Kubernetes clusters. And of course, for the nodes of these clusters, back to this operating or Linux distribution question, of course, we also develop Garden Linux as one choice, but in the community, it's also popular to use Ubuntu or SUSE or maybe CoreOS, and maybe many others. Now you might be saying, okay, now we're seeing a talk about a custom Kubernetes distribution that SAP is building. That's not really the case. So we participate in the Cloud Native Computing Foundation's certified Kubernetes program. It gives you this complicated map that you might be used to in the Cloud Native space. But if you look closely, you will find the Gardener logo at the bottom here for the certified Kubernetes installers. Since we participate in this program and prove that we fulfill the standards for Kubernetes distribution. And since we use that to operate the Kubernetes landscape at SAP, you will find the SAP logo again for the certified Kubernetes hosting platform. And you can find all of these test results either in our documentation, where you can see the major infrastructure providers that we support, along with the Kubernetes version that we support, or you can also look up the test results or see how the tests work themselves. All right, that brings us then finally to the mission statement that we defined for Gardener. Basically, what we want to achieve is that we want to provide a way to run a managed Kubernetes service that is done right. Obviously, that last part is a bit opinionated, but what we mean by that is, of course, we want to be able to run homogeneous Kubernetes clusters. All of this is done open source. It has scalability built into it. There's autonomous features that help you with certain typical operations. It is ubiquitous, meaning you can deploy it really anywhere in the cloud, on-premise, on self-hosted infrastructure. And finally, as we've seen before, it is also certified in this program, and there's certain compliance features built in that you need in certain contexts to run or operate compliant cloud services. All of this you can also look up on our homepage, which is gardener.cloud. So the question now is this just another SAP commercial for something we're developing? Well, we hope not, because actually all of this is open source, as we've talked about before. You can find it on github.com/Gardener. You will find the main repository, which is Gardener itself, but there's also many other repositories, for example, for our etcd Druid operator that we'll come back to. There's the machine controller manager that we'll hear again. There are many extensions for all of the major cloud infrastructure providers, but also for OpenStack. And some of these are even not part of the Gardener organization, but actually contributed by the community. And of course, extensions for the network interface or for the operating system or for typical use cases that you might have, such as certificates or managing DNS entries or even others. Now, that brings us to the question, well, is it truly open source? And maybe, Niklas, you can shed a bit more light on this next topic.
Yes, I'm happy to do so. And now that we have seen that Gardener is already open source, maybe let's take a step back for a second and have a look at some other open source projects. And you might have heard of those here. So for example, Elasticsearch, Terraform, Grafana, and many more. And if you have worked with them in the past, or maybe you are still working with them, you might already know what I'm hinting towards to. So those components or those projects have all something in common. And in that case, it is that they had a recent change or somehow recent change in their licenses. And usually this is towards a more restrictive license. And we really don't want to blame any of the companies behind that. So there might be reasons to do that, but usually it is coming with complications for the consumers of those projects. So in general, I would argue that it's always not the best idea to have a single commercial entity being able to dictate the whole course of a project. And actually, we have been asked questions around that also for Gardener. And then we can, of course, say, yes, we do not intend to change any of our licenses, but it's even better to give it some more weight. And we really want to make sure that Gardener is not showing up in the future on a similar slide like this one. So what we did is we found the answer in NeoNephos. And NeoNephos is now a foundation. You might have heard about it also in the introduction of this whole talk here, and maybe some of you are even already members. But this is a foundation which is dedicated on advancing open source projects that align with the strategic objectives of digital sovereignty within the European Union. And now with NeoNephos, we do not reinvent the wheel from scratch. So let's have a look what it's done there. So NeoNephos is similar to the Linux Foundation Europe, and actually it is a child or a sub-foundation of the Linux Foundation Europe. So it's based on that, and what has now been done is Gardener is being donated to NeoNephos, and actually it's more than just Gardener, so there's more coming also from SAP to NeoNephos, which we call Apiro Reference Architecture. So under this umbrella of the Apiro Reference Architecture, SAP is donating a bundle of projects to NeoNephos, and these projects include Gardener, but also, for example, Garden Linux or Iron Core or Open Delivery Gear, if you heard of any of those. And the whole idea behind this Apiro reference architecture is that it's positioning us as some sort, or that is positioning the projects as a backbone for a flexible and powerful and yet secure and compliant cloud edge continuum, or even a next generation cloud edge continuum, if you want so. And in that cloud edge continuum over Europe, it's that Gardener makes up the layer of the cloud operating system. And why are we doing that, you might now ask? And the answer is, yeah, we are doing it because this reference architecture is playing or is crucial for the role that SAP is playing within the IPSATE sys. And if you have not heard about IPSATE sys, let me introduce you what it's about. It's abbreviation for important projects of common European interest. So it's a European project, actually a really, really big project. And CIS is for Cloud Infrastructure Services. So in essence, the European Union noticed that it might not be the very best idea to be completely dependent on non-European hyperscalers in the future, but it would be nice to have something for a sovereign environment on European soil, so to say. And with that in mind, now we have seen that we have Gardener here positioned in the NeoNephos Foundation. The NeoNephos Foundation is some sort of vehicle to make sure that the projects inside that foundation stay truly open source and vendor neutral. And SAP's contribution towards that is within the Apiro reference architecture to the ipsate sys. And there's a slightly different way to have a look at it if we condense it slightly. So still here the Apiro projects, but there is more to it. There are more countries working on that even. And this all comes together under the ORA initiative. So the ORA initiative is an initiative that really tries to tackle this fragmented European cloud landscape. And also this uses ipsate sys as some sort of cornerstone for this whole initiative. And with that, maybe let's have still a bit deeper look into NeoNephos. So as I said a couple of minutes ago, we are not trying to reinvent the wheel from scratch. So yeah, there are principles that you might know. And the whole structure essentially is similar to others. So NeoNephos has a governing board. So that's the very first thing. The governing board is consisting of members, and those members are usually paying for membership, but there's also a free membership for some sort of observer seats. This governing board is made up out of these members, but contributing to that as a technical advisory layer, there's this technical advisory council. And while this whole governing board lays out the vision for NeoNephos, this technical advisory council is giving the technical oversight. And this one is now made up of steering committees, technical steering committees, and these are on a per project basis. So each project has its technical steering. So for example, Gardener has one, and then each of those steering committees has a chairperson, and this one is then building up the technical advisory council. And even that council now has a position in the governing board. And as I said, it's a per project level, which means here that could, for example, be the Gardener Technical Steering Committee. And while you can be a member for the governing board or for in the foundation by paying for it and joining the foundation in the technical steering, you can also become a member by contributing and being recognized by the community. So that's about the background for the open source part and how it all works and how it's embedded and why we did that. Now I think it's time to jump back a little deeper into the architecture and see how Gardener really is doing all that. So the whole idea is that we really try to use Kubernetes native principles. So while Gardener really builds on these ideas around reconciliation and having a desired state, so the desired and the actual state, all those things, I guess, should be known to you if you are familiar with Kubernetes. And what we usually have is we have an entity that is called a shoot, and you see it here. So it's, in essence, a YAML file describing the desired state of your cluster. So when we talk about clusters, we talk about shoots. We have this botanical theme for obvious reasons going on. And what's now happening is we take this shoot, this description of the cluster, Kubernetes, in the sense of Gardener, will take care of it. And you have these typical reconciliation loops like observe, analyze, act. So this one. And now the desired state is turned into an actual state. So you will end up with a cluster. And when we talk about a cluster, we mean you have your control plane and you have your worker nodes where your stuff is running on. Okay, now let's have an even deeper look into that. I want to focus on this shoot for a second and tell you what it's made up of. And you hopefully know those components. So this shoot cluster, this consists of a typical Kubernetes node. And on those nodes, you have your typical components that are installed on all nodes, like a kubelet to communicate with the control plane. You might have other components like a CNI or even more. Then you have your workload, and your workload is typically in pods. And in the pods, you have your containers. And now you might even have more of those nodes, so multiple of them. And also, just as typical, you need your control plane. We have seen that already. And the kubelet talks to the control plane. Actually, it talks to the kube API server, and we also have the other well-known components like the kube scheduler, the kube controller manager, and the etcd. Now, the whole idea behind this Gardener concept, and the concept which is also often referred to as hosted control planes, is that we are now able to put those components here on the left also inside containers and let Kubernetes handle them and gain advantage of all the Kubernetes benefits that we have. So this means we have the API server as a deployment, the kube scheduler as a deployment, the controller manager also as a deployment, and technically the etcd is a stateful set. So this now can be isolated with a namespace drawing around it. And now we end up with what we call a seed cluster. And this seed cluster is now the control plane that is hosted also in Kubernetes. And technically, again, we would now need a load balancer, but let's ignore that for a second if you have also multiple of those namespaces, which would be possible on a seed. But now you can already see we have a shoot and we have a seed cluster, and also Kubernetes takes care of the seed cluster. And we now would need another cluster to really manage that. And this is also why we often refer to it as kubeception. So, and if you haven't seen the movie Inception, where this reference is coming from, then just give it a try. It might be a bit older, but it's a nice one. And now let's have a look how it looks like if we really dive even deeper into this now. So you have a shoot cluster, you have the seed cluster. Let's condense that for a second. And we put the shoot cluster now on a dedicated infrastructure, for example, OpenStack, because we want to have a digital sovereign European Union. And now the shoot cluster, still the same picture, essentially talks to the shoot control plane. And as I said already, we can have multiple of those on the same control planes on the same seed cluster. Now we have the garden cluster that takes care of the seed, and it's also a typical cluster with the typical components that you see here. And if a user comes now and says, and it now communicates with the shoots via the gardenlet. So the gardenlet is the counterpart, so to say, to the kubelet. It follows the same principle and is exactly that distinguishes our shoots from the seeds. So we have the gardenlet that is communicating to the garden cluster. And if now a user comes and says, hey, I want to have a shoot, he takes a shoot YAML, so essentially this description that you have seen as this blueprint thingy, and applies that to the garden cluster. The garden cluster now communicates with the seeds via the gardenlet, and Gardener takes care for creating your desired shoot. And now you can even go and say, hey, I would like to have even multiple of those seeds. You can do that. You can put them in different regions. You could also have hybrid setups where you have a seed, for example, on OpenStack, and for latency or network cost reasons, you might want to put other seeds somewhere else. So you could put them on GCP, Azure, or wherever you want to. And now this gives you the overview of how Gardener works roughly under the hood, so the basic principle. And I think it's now time to really have a look how it feels and how it looks like in reality. And with that, I can give back to Mark.
Thanks a lot, Niklas. I am delighted to give you this demo. So up until now, we've seen a lot of talking from us and a lot of slides. So let's take a look at one visual representation of what Gardener is. What you're seeing here is the so-called Gardener dashboard. That's another component that you can use and run to basically provide a UI for a so-called Gardener landscape, so a hosted Gardener service. Here I'm using one of the landscapes that we operate here at SAP. What I did already is I created a project, which is basically a logical group for one or many Kubernetes clusters, a group of members, be that humans or technical users, and a set of credentials available in this project. You see at the top that I can make the choice in this landscape between the major cloud providers. There's also Alibaba Cloud available here. I can run on the OpenStack infrastructure that we operate, or there's even if you're not familiar with Iron Core, there's an on-metal Kubernetes hosting available here. This dashboard now helps me basically to get through this provisioning dialog for a Kubernetes cluster. I already pre-filled a cluster name here. We talked in the beginning about the requirements of provisioning a Kubernetes cluster. So you see, I need to make a choice of the Kubernetes version I want to use for this cluster. The Gardener landscape helps you here in the sense that it provides these guardrails in terms of saying a certain set of versions are considered supported, but they already have an expiration date. Some of them are deprecated, will eventually be removed, and there's even preview versions available if you want to jump ahead. You can also declare the purpose of this Kubernetes cluster, which is for semantic, sometimes also technical reasons. We can fill in the infrastructure details. This is already taken care of here, but what's maybe interesting is that I can choose a region. I will now pick a European or an even German region for operating this cluster. I can pick the container network interface. I will stick with Calico instead of Cilium here. What you also get out of the box is, if we talk about these features that are baked into Gardener to give you an enterprise-ready setup, so to say, or maybe a setup for operating compliant cloud services, you can enable your control plane to be highly available, meaning the components of the control plane will be distributed across multiple zones. So they're basically tolerant in case of a zonal outage that your control plane is still up. And of course, you can do the same for your own workload that you operate with a zonal high availability. Jumping ahead a little bit, you have the option to mark your cluster with certain regional restrictions, such as, for example, a EU-only access that you can use in your own operations to make sure that only EU personnel, for example, takes care of debugging or looking into problems or looking into this cluster at all. And most important, the worker section for our cluster, where we basically configure one or multiple pools of nodes that will be available in this cluster with certain characteristics. So for example, we can choose which machine type we want to have along with their characteristics in the infrastructure that we picked. So this is our OpenStack infrastructure. We need to choose the operating system or Linux distribution that you can see here. Again, they follow the same classification pattern of saying certain versions are supported, some are deprecated, some are in preview. These guardrails that you can define for your landscape. And you can make choices about how this pool of workers should scale in case the cluster requires more nodes to operate the workload. Moving down to the bottom, the maintenance window is quite interesting. That's basically a time frame in which the Gardener controllers know that they can schedule and apply changes to your cluster. Changes meaning, for example, you could update the Kubernetes version, you could update the operating system version, or maybe if updates to Gardener itself have been applied, this would only happen within this maintenance window. So you can make sure that that fits what your workload requires, maybe sometime during the night or on the weekend or whatever. And finally, just to highlight maybe a feature that's nice for development, there's the so-called hibernation schedule. Basically allows you to define a schedule based on the days of the week and a time and time zone where you can, if you want, define that your cluster should go into hibernation, meaning it's basically tear down. All of the components that constitute it are removed. Only the state is kept in the background. And this is primarily a cost-saving feature, right? Imagine maybe you have a development cluster that your engineers only need during the week, during work hours. Then you define that your cluster is up and running during these core hours. But if you don't need it, this hibernation schedule will put your cluster to sleep. Since I picked a purpose of production at the top, I don't think it makes sense to use a hibernation here, so I'm removing it again. Now this is just the UI dialog. Maybe you've spotted it already at the top. I can switch to this YAML tab because what Niklas actually talked about is right that we stick to all of these Kubernetes principles and primitives. So the shoot cluster is just represented as another Kubernetes resource in YAML if you want to. So you can always drop back to the YAML view if you really want to control how you want to configure your cluster or take care of certain settings that are not available in the UI. And maybe you see some of the choices that we made before again here in this YAML. For example, that we want to run on OpenStack, or that we define our worker pool along with the operating system and the machine type that we want to have. We wanted to stick with Calico and run a certain Kubernetes version, and so on and so forth. Now, if I'm happy with all of those choices, I can just hit create, and then Gardener will basically get started off provisioning and setting up this Kubernetes cluster for me. If you think back to this architecture that we've seen before, so now these things are happening that we need to find a seed cluster that can host the control plane of this cluster. And of course, Gardener needs to talk to the infrastructure and provision the nodes that will then join this Kubernetes cluster to be actually able to host the workload. If I drop back into this cluster view here, you see that I have a few other clusters of type evaluation already created. They're currently sleeping, meaning they're hibernated, not active, but you see they run on all of the major cloud providers. And the new cluster we've just created is now in the process of being created, which takes a couple of minutes basically until the control plane is ready and until the machines have been provisioned on infrastructure side. Now, this is just one interface for interacting with Gardener. As we've said, it's really just running Kubernetes again. So essentially the dashboard is also just talking to the Kube API server or to the Gardener Kube API server here to do all of these things. So I hope I'm not losing some of you when I switch to the terminal here, just to give you a different view at the same thing. I will now use kubectl to look at a few of the same things. So I'm connected against this garden cluster here. What I can say is I can say kubectl get shoot, which will get me the shoot clusters, the same list that we've just seen in the dashboard. You can see the ones in hibernation, the ones that are awake, and of course the new cluster that we created, which is still in the processing phase. And since Niklas also showed it in the architecture that we can just kubectl apply a shoot cluster, I just prepared something here. Let me just show you. I have a little YAML template for a shoot cluster already prepared, again running on OpenStack, just in a different region in this case. And if we want to make this cluster reality, we just apply it. Kubernetes tells us, okay, this has been created. And if I pull up the list of my shoot clusters again, you see a new entry that we have now an OpenStack cluster in the EU Netherlands region, which is just starting to be processed. Okay, so much on the view on the garden cluster itself. We will now just fast forward in our head a little bit. Imagine these clusters got created already and they're now ready to be used. So I already pointed the session here against the created cluster on OpenStack. So we can ask kubectl, hey, tell us what namespaces are available. Of course, have the default namespace and a few system namespaces. So let's see how many nodes we have. We actually just have one node. Maybe there's not a lot going on inside this cluster. But in the naming, you can already also tell again, we're running here in Europe, in Germany. And if we check which pods we have available, let's find out what by default we have here. You see a few system relevant pods that we need for Gardener to work properly, or also for your cluster to work properly. But what you might be missing is you will not find anything about etcd here. You will not find anything about the Kubernetes API server apart from this proxy pod here at the top, or all of the other components that constitute the control plane. If you think back again to the architecture slides, the control plane is not running inside this cluster. It's actually running in the seed cluster. This connection I also already prepared down here. So I'm pointing to the seed cluster that is hosting this OpenStack cluster. And I switched to the namespace that you can see on the right side here, which is basically holding all of the things that constitute the control plane of this Kubernetes cluster. So if we ask for the same thing here, let's see what pods are available. Now it might be a little bit more familiar in the sense that we see there are etcd pods, there are components from Gardener that we need in the control plane, but of course there's also the Kube API server now running inside this control plane. All right, moving back from the demo to our slides. I just want to recap or highlight maybe a few things either that we've seen or that we've seen implicitly. So one of the core components that are important to Gardener is the concept of the cloud profile. Again, going back to the beginning of today's session, if you think about these guardrails, then the cloud profile is really this core component that helps an operator of a Gardener landscape or operators of a Gardener landscape to define them, because basically the cloud profile contains, okay, if you pick this profile, what Kubernetes versions are available, what is their classification, supported, deprecated, preview. Same is true for the operating system versions or these machine images for the Linux distribution that we use for the cluster nodes. Of course, depending on which infrastructure you pick through your cloud profile, only a certain set of regions are available. And through the cloud profile, I can, as an operator, maybe even restrict that more. And of course, the machine types are also bound to the infrastructure. And maybe I don't want to make certain machines, maybe certain expensive machines not available in my cloud profile for various reasons. And all of these details, these requirements, or these guardrails are represented as the cloud profile resource inside the Garden cluster. And we implicitly interacted with this cloud profile without knowing about it by basically in the dashboard going through this dialog of saying, okay, I want to be on this infrastructure. These are the versions that I want to pick. All of this is basically governed by this cloud profile. We talked about the seed cluster hosting one or many shoot control planes before. Just to recap here a bit, if you've noticed in the slides before, well, what is the gardenlet? If you're familiar with the kubelet is basically what Kubernetes uses to turn a VM or a server into a cluster node. Just deploy the kubelet on there, then it will join the cluster. We use the same concept for the gardenlet of saying, okay, I have a Kubernetes cluster. I put the gardenlet on top of there. It becomes a seed cluster, joins the garden, and is then able to host shoot control planes on there. The gardenlet is, of course, then the central component, always talking back to the garden to know, do I need to do something? Do I need to host a new control plane? In the puzzle piece of the open source components making up Gardener, you might have already noticed the etcd druid component. This one works with or without Gardener. We use it basically to have a way of using custom resources to specify etcd capabilities. And then this druid will basically go ahead, turn that into a stateful set of running an etcd cluster. And this even has a sidecar which takes care of typical maintenance things on a regular basis. And it actually does a continuous backup and restore. So this is also maybe a typical requirement that you need to have backup and restore capabilities. We also talked about the machine controller manager. This is basically the central component or abstraction for Gardener to talk to these various infrastructures to then be able to, I need machines and I need to join them into the cluster as a node. It uses familiar principles here, so it works with the concept of a machine class to represent what are the different choices that are available. It then has a machine deployment, which in turn spawns a machine set. So you can think of these as just a Kubernetes deployment and a replica set, which end up as machine objects that then MCM or Machine Controller Manager will use to phone up the API of the infrastructure, whatever that might be, to say, hey, please provision this virtual machine, this server, or whatever it is. And then it takes care of making sure that this joins the cluster as a node. All right, with that, we cover how Gardener works, both by looking at the architecture, but also taking a look at, well, how it works in reality. We want to come back a little bit to the context of NeoNephos that Gardener now operates within. So taking a look at the journey ahead. So up until now, as we've talked about, Gardener is developed open source, but obviously this is to some extent with priorities that we needed at SAP to develop the project. Of course, we take input from the community already before NeoNephos to develop or others contribute components according to their needs. But now with NeoNephos, some of these priorities, or also this capacity that we have, shifts a bit. One of these major topics, to give you an example, is the umbrella topic of landscape documentation or installability, if you want to use another term. Basically, we want to make it much easier for others to say, okay, this is really cool, but now how do I set up my own Gardener landscape? How do I get started on my infrastructure, be that a cloud provider or some on-premise that I have available? And we want to do that both by investing into our documentation that helps you to do that, also by defining best practices, tooling that you can use, or we're already doing it with work streams such as the Gardener operator, which really automates a lot of things that used to be manual tasks. It just helps to set up Gardener in an automated fashion and a reliable fashion. Another one of these major topics is the topic of autonomous shoot clusters. What's behind this, this concept? Well, it solves two problems for Gardener. If you now actually go into our getting started guides and need to find out what you need to do, well, you need to start with the Kubernetes cluster somehow, even before you have Gardener. The autonomous shoots is now one answer where you can say, well, how do I get this initial Kubernetes cluster to begin with? Autonomous shoot clusters will help here to have kind of a self-bootstrapping mechanism. But this topic also helps in all of these scenarios where maybe you have something air-gapped, where you don't have internet connection in between. Maybe you have an edge scenario where there's just no Kubernetes distro provided by the infrastructure, but you still want to run Gardener here. This is where autonomous shoots come into play. And if you're interested in any of these topics, we also follow the same principle that Kubernetes has with the Kubernetes enhancement proposals. We have the Gardener enhancement proposals, or the GAPs for short. So you can dive into all of this in these proposals and find out more, and then even participate in these topics if they're relevant to you. Now, finally, to wrap up today's session, to give you a few final words, if all of this piqued your interest, and we hope it did, there's two major ways we want to propagate where you can get started if you want to. At the top here, you see our demo environment, which you can find at demo.gardener.cloud. This is a pre-made environment where you just dropped into a virtual shell session, along with a guided tutorial at the right-hand side, which walks you through a lot of the same topics that you've already heard about today, basically answering what is Gardener, what are the different components, and at the same time, you need to do things inside this terminal following this guide. If you're more of the person who says, I want to really work with it myself, and you have a beefy enough machine, let's put it like that, there's also the option of running your own local environment on your device using Docker. So you can deploy a Gardener landscape into that. You can even run the same dashboard that I showed you before also on your own machine connected to this local landscape and play around with it. Just highlighting again that this is really meant just for experimentation or development on your own machine. This is not for productive purposes. We also really want to motivate you if you like today's topic, then please do join our community. There's various ways on how you can participate. Of course, you can join us on GitHub. You can contribute either by opening issues, discussing in existing ones, or of course, open your own pull requests. If you're not happy with something or you want to have a new feature, feel free to contribute by opening pull requests. We also want to highlight our Slack workspace. You can join that, really ask questions as much as you want, and talk to us, and also talk to others in the community that might be on the same track as you. If you're also just setting up Gardener on OpenStack, maybe you will most likely find somebody else in our Slack community doing the same. We also have a YouTube channel. You can rewatch, for example, our community meetings there. There's various meetings on the product, on the technical side, but also on recent developments. And if you don't want to rewatch things, then you can also join these community review meetings live by joining us on Teams. This might help you to keep up with the latest developments in the Gardener ecosystem. Or if you're already part of the community or have contributed your own thing, you can also consider presenting yourself. We're always open for contributors in these meetings. So a few final words, what you can take away from today's session. So what is Gardener? Gardener helps you to manage both the life cycle, but also a fleet of Kubernetes clusters, and that all across different infrastructures. It is meant to be vendor neutral. It is meant to be open source as much as possible and put under this foundation governance under the NeoNephos umbrella to hopefully stick to this promise that we made. And finally, within this whole research context from the EU and from all of these member countries in the various projects, Gardener is positioned as this cloud operating system layer for the cloud edge continuum. That sounds all a little fancy. It just means you can use Gardener as this abstraction layer for having homogeneous Kubernetes clusters across any infrastructure and any deployment scenario. And with that, before my voice breaks even further, thanks a lot for listening to us today. And if you have questions, I believe you can put them in the chat or unmute yourself. And then we also have time for questions.
Thank you very much, Mark and Niklas. I think that was a great overview, very nice demo. And yes, luckily we still have some time. So as you mentioned, I just unmuted everybody who wants to speak up, and I'm also having a look at the chat. And at the same time, I will also share the link for replays in the chat. So, and by the way, let me announce also another webinar which we have in the context of Apeiro and NeoNephos. So we are planning a webinar on confidence. That's a new project. It's not yet open in GitHub, but it will be open sourced. And I will put the information and details also in the chat. So if you're interested, just check it out. Now, yeah, we have a question by Mamet, and he is asking, what are the existing CNCF projects which will be coming under NeoNephos. Yeah. Okay. So that's maybe a question where you didn't mention about life cycle of TLS certificate. So it's basically two questions, I think. What will be coming under NeoNephos? So I just mentioned confidence. So that's a new one. And maybe that's a question which can be answered by a link to NeoNephos and the projects, or even some colleagues. I don't know whether Mark or Niklas are the right persons, but we have some colleagues also here in this webinar who can speak up, of course. And the life cycle of the TLS certificate. Who can answer this question?
Since I currently can't see the chat, could you read out the life cycle of certificates questions to me?
Yeah. You didn't mention the life cycle of the TLS certificate.
Okay, that's fair. I did mention it briefly, but then never really came back to it. We really just wanted to give an example of what a typical thing is that you need for running a Kubernetes cluster, right? Most likely you want to provide your service as TLS encrypted and need to answer this question somehow. And one of the solutions that you can use is, of course, there's the CNCF Cert Manager project that you can use to do this. In the Gardener context, we provide the so-called shoot cert service, which also helps you to take care of the same. So you can use it to provision, for example, certificates from Let's Encrypt through the ACME protocol. You can also run your own certificate authority or work with self-signed certificates if that's something you need. And regarding the lifecycle, it helps you in that sense that it, if we stick with the Let's Encrypt example, it takes care of automatic renewals, right? So before the certificate expires, the controller will take care of renewing it, the same which also the public CNCF Cert Manager does. Hope that answers it. I can also drop the link again to this project if it's interesting to you.
Thanks a lot, Mark. And I see in the chat there's also a reference to new projects, and I also put the link to the confidence webinar on
I think
November
I could have
4th.
named a few, but definitely not all of them. So it's better to visit the NeoNephos website directly.
Exactly. So are there any other questions? Please raise your voice or raise your hand first. Use the chat. I have a question which was kind of addressed previously to me. So what about community-driven activities in the NeoNephos context with the Gardener project? Is there anything going on? Are there any upcoming events maybe, or something you want to refer to?
I think one prominent example that we can make, there's of course lots of small things going on here and there, but one of the more prominent examples is exactly these autonomous shoot clusters that we talked about before. For example, the folks from Stack IT from Schwarzgruppe, they are joining forces with us here to work on this topic, to discuss where we want to take it, in which direction, and then actually contribute all of the little pieces that we need to make it reality. So I think that's one of the most prominent examples at the moment.
Okay, thank you very much. And there's another question. Are there plans for adding support for Proxmox for instantiating? Oh my God, machine instances.
So we ourselves don't have those plans, but there's basically blueprints or guides available if you want to implement your own provider. Others in the community have done that in the past. I mean, from us as the Gardener organization, if you will, we can't implement that for all providers. But again, we have documentation available. There's examples on how you can achieve this for whichever infrastructure you want to run on. So it's definitely possible to do so.
All right,
but no plans from us.
Thank you. I mean, since there is a couple of external participants, so anybody who wants to also, raise any question related to NeoNephos again, how to participate, or also learning more about how to get involved maybe in the Gardener community. I think that's a nice option here to get in touch also with main stakeholders like Mark and Niklas. Otherwise, if there is no more questions, I'm checking in the chat. There is no more question there. We still have a couple of minutes. Anybody who wants to raise hands, or if not, I would say thanks again, Mark and Niklas. Was really fun with you. Also the prep time and now great session, and thanks a lot for anybody in the audience, for anybody listening, and looking forward to more sessions in the NeoNephos and Apeiro context. Thanks everybody. Bye-bye.
Thanks for joining.
Thank you.